Okay, what's up, guys? This is all for my high school students. So I know, some of my college students are waiting for lesson 4. It's coming very, very soon. If you're watching this, I, if you are, cool. But this is definitely just for my high school students. Okay, so my high school students are taking geometry. This is all going to be about geometry, not statistics. So the very first thing we talk about in our first lesson is, and correlates to the lessons they're learning in school right now, is all about basic definitions that you see within geometry. So for instance, for an outcome, we're just going to basically look at all the basic definitions in geometry, just like the ones that are going to start us off. And we're also going to look at different types of pairs of lines. Okay, so a point, by definition, is something without length. Or width or height, really. It's really zero dimensional. So we express this by just having a point. Most people call it a dot. I let that go just because it's really good, actually, for people to kind of visualize what a point is. But in reality, it's just a representation of nothing. But that's point A, which we call point A. We have all kinds of points anywhere. You can think of the points as stars in space, even though in reality stars are very, very, very large. But to us, while we're on the Earth, the points are pretty much just like the stars are pretty much just like points. Then we have lines, and lines by definition are a collection of points that extend forever in two directions. Okay, now right now my students are getting a reprieve because they're doing online learning. They don't have to necessarily write the actual symbols behind all this, but when I look at line AB here, in reality, if I'm going to draw it, I need to write it as AB with this little line symbol on top, and BA with the little line symbol on top. Or we can just call it, and that's what I've been letting my students online doing, just call it line AB, because it's really, 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 really hard to affix these things right here to when they write their answers down in to respond to me. So I'm pretty much letting that go at this point. But for future generations, when I want to use this video again, or future years rather, get generations, but future years, we will emphasize that going back in when we're back in the classroom. Intersecting is really easy. It's when two lines cross, or really it's just the act of two things crossing. I guess you didn't have to say two lines cross, but basically two or more of anything crossing. It's the act of crossing that is the intersection. When I intersect, I am crossing. Okay, so I have my two lines have intersected, so they're crossing. Okay, and we'll talk about what happens when two lines intersect in a second. Okay, so I'm gonna flip it over. Then I've got different types of lines. So the first type of lines are parallel lines. Now, there is a slightly better definition for parallel lines than what I'm about to write, but I haven't introduced one word yet, and so I might reword it when I get to that point. and I'm not going to introduce it in this lesson, but for right now, we're just going to say that parallel lines are two lines that never intersect. Like I said, technically speaking, that you'll see when we get to skew lines, it's not 100% the correct definition, but it's good enough for right now. Like I said, I haven't actually introduced one word yet, which would be helpful to go into it. But for instance, A, B, and C, and D. And what we say is AB, line AB is parallel to line CD. So in reality, that is the symbol for parallel. Okay. Then we've got perpendicular lines. Something that I'm really these two here are big important definitions that I'm really going to want my geometry students to remember throughout the entire year, but they never do. So hopefully they'll take this comment when they look at this video and be like, oh, I really need to memorize these, but we'll see what happens. But there are two lines that intersect to form right angles. So what it looks like is basically them crossing just like this to form right angles. And so the symbol, let's call this A, B, C, D. So AB is perpendicular to CD. And this is again the sign for, not sign, symbol for perpendicular. Okay, so and that sign makes a lot of sense. Like this sign here for parallel makes sense because it's literally two lines running next to each other that are not intersecting. And this sign makes sense because it's upside down T that forms two right angles. Okay, the last set here is one that you're probably not used to. It only occurs in three-dimensional spaces. So this is it only occurs in 3 dimensions. And so basically these are lines that do not intersect but aren't parallel. So it's really hard to imagine, but you have to, if you're in a three-dimensional room, we're all in three-dimensional rooms. I don't know why I said that, but if you're in your room, think of it as the line that connects the ceiling to the wall to your right, and then the line that connects the floor to the wall all the way behind you. Those would be skew. Or as another visual representation, imagine this marker is a line that goes left to right. Then this marker here is above the line the whole entire time and going up and down, or I guess forwards and backwards. That would be skew lines. One is perpetually above it. There's space, there's air. It's always above it. It's always going a different direction. They are not intersecting, and they are not parallel to each other. So that would be skew lines. Okay? There is no symbol for skew. They're skew lines. Okay. So some examples that we can see here. Point's pretty easy. I mean, you can just go with anything. A, B, C, D. Line, technically there are no lines. They're all segments, but we're going to call them lines anyway, just because. So line AB line AD, line CH, whatever you want. Now, parallel, this is what I want to get into, and I don't really want to worry about intersecting lines. We have a rectangular prism here, which we'll look at way later down the road as to what that exactly is. So there are going to be right angles in there. So we want to talk about perpendicular lines too, but let's start with parallel lines. If we look at an example, parallel lines could be AB and BC. They run uniquely. Oh, AD rather. AD and BC. Don't know why I said it like that. Because they run next to each other and they never cross each other. I'm also going to go ahead and point out that DG and CH are also parallel. Now, they're parallel to each other, just not necessarily parallel to that set over there. But they are what they are. Okay, that being said, when I look at this, if I look at some perpendicular lines, well, AD is definitely forming a right angle with DG. So we're going to say AD is perpendicular to DG. And BC is definitely perpendicular to CH. That's a right angle. And don't get this mixed up with intersecting. Perpendicular, you really do have to have a right angle. That's why I chose this particular shape, because it's basically all right angles. Skew lines. So let's see what an actual skew line looks like. So you have to imagine this in a 3D setting. And so if you think of GH running towards you and BF in the foreground going up and down, those are skew lines because they are never parallel and they're never going to intersect. So BF is skew to GH. Again, there's no real symbol for skew. And then we could say AE and FH are also skew, because again, this one's up and down, and this one's running back left and right into the background. Okay. So we got our examples. Okay, a couple more definitions for this particular lesson. We got a plane. A plane is a flat surface. It is not the one that flies in the air. It's a flat surface that extends in all directions except in height, because this is a two-dimensional object. And if it extended in height, that would make it three-dimensional. We want this to be two-dimensional. A good example of a plane is just the paper itself, or like this thing that I use to shoot videos on. This is nice and dark and you can't see anything. It kind of contrasts with the color of my skin. Maybe it doesn't, I don't know. But a plane is a flat surface that extends in all directions except in height. Parallel planes would then be planes that don't intersect. And of course, intersecting planes would be planes that cross. You can have perpendicular planes. You can have them crossing at right angles. You cannot have skew planes. That is impossible. I guess technically speaking, you could have it in fourth dimensions, but we can't see fourth dimensions, and we're not going to go into that kind of tangent. So that's my last of my definitions here. Let's talk about this. These are pretty much a lot of true-false questions. Are planes A, B, D, C parallel to E, F, H, G? And the answer to that is yes. They will never cross. They are two flat surfaces that will not cross. The next question says, are they intersecting? Well, if they're parallel, they cannot be intersecting, so the answer is no. Give an example of two intersecting planes. Now, technically speaking, a plane can be named with 1 letter, 3 letters, or 4. But because my students have a hard time with the 1 letter thing, I don't let them name them with 1 letter. I mostly tell them to name it with 4. So, I'm going to go ahead and say plane A, B, D, C, and plane B, D, E, G. Okay. Name 3 names for plane E, G, D, B. So what you can do is you need to keep the 4 letters that are there, but you can rearrange the letters to meet your needs as long as they're going in the right order. I usually just tell my students to move the next letter over, and that will be your names. That way, they stay in the right order the whole entire time. So G, D, B, E, D, B, E, G, E, B, E, G, D. What is the intersection of planes A, B, D, C and planes E, G, D, B? Well, 2 planes, and we're going to ready to fill this in a second. 2 planes will intersect at a line. So, we got A, B, D, C, and E, G, D, B right there. They're going to intersect at this line here. B, D. And you can kind of see that because BD is contained in both of the planes. So that's a good hint to it. Alright, final point. We have what's called postulates. Later we'll have something called theorems, but we're not quite there yet. A postulate is a rule in math. Specifically one that does not need to be proven. Okay, the 2 we're going to talk about is 2 lines intersect at a point. And 2 planes intersect at a crash. Wait, that's the wrong type of plane. 2 planes intersect at a line. Okay. Hopefully this helps my high school students.